Everyone. Today we'll see a design of fuzzy speed controller for motor using MATLAB. So these are few commands to implement that fuzzy logic controller in MATLAB. So graphical user interface editor tools. Fuzzy, if you enter that fuzzy command in MATLAB command window, you'll get the basic FIS editor, that is fuzzy inference system editor you'll get it. So MF edit means membership function editor, rule edit means rule editor, rule view means rule view editor you'll get it, and surf view means output surface here you'll get it. So these red color words are commands. Those commands you need to enter in the command window to get the respective features in the MATLAB. So for example, if you enter that main command window, that is fuzzy, you'll get the FIS editor like this. So this is Mamdani rule based editor, FIS editor, fuzzy inference system editor. Here you'll get input, output. Input is used for fuzzification, output is for defuzzification. In between that untitled Mamdani is right, that white color. So that is to frame the rules. That is rule based system. So this is another type of editor, FIS editor with Sugeno rule based editor. So again here also input and output is used for fuzzification and defuzzification respectively, and Sugeno rule based editor is used here. And if you enter that again all those commands, FIS editor, then FIS membership function editor, you'll get it like this. So here you need to give the membership function. Default membership functions are 3, so MF1, MF2, MF3. If you want to increase the membership functions, you can increase the membership functions also. Depends on your problem statement. You can go for various membership functions. So here, as you are increasing the membership functions, your complexity of the problem will increase. Likewise, for output also, you need to give the membership functions. And this is FIS rule editor. So here, after you give the membership function for the input and output, if you see here, if input 1 is that MF2 is highlighted, if input 1 is MF2, then on the right side if you see, then output 1 is MF3. As you will see that speed control, if input 1, let us take it as speed, output let us take it as voltage. If speed is low, then voltage is high or voltage is increased. Likewise, we can frame the rules, and those rules will be added to that FIS rule editor. So based on that rules, this fuzzy logic controller will work. This is FIS rule viewer. So here, if you change that vertical red line in the input at 0.5, if it placed means the corresponding output is 0.87. Based on our rules, that will change, because if you are moving that input a little lesser than that 0.5 means your output will change corresponding to the rules. So likewise, we can see the rule viewer here, and this is FIS surf viewer. So how to plot that graph, even 3D graph also you can plot if you are having multiple variables, more than 2. So here, as we are having only input and output versus input graph, we can get it. So like this. So all these things will implement in the MATLAB. So let us first, I'll clear this command window, CLC. Now you enter the fuzzy. If you enter fuzzy, then you'll get the FIS editor like this. And here input 1, I'll take it as speed, and output as voltage, then editor membership functions will decide later. First you enter on the speed, then here you can frame the, you can give the membership functions is MF1 is I'm using it for low speed. If speed is low, this is low membership function, and the corresponding range of speed here I'm considering as 1000. So display range will also change. Now it is 0 to 1. Now display range will also change from 0 to 1000. The corresponding low membership function, instead of starting from minus 400, let it be start from 0 0 and up to 500. So below 500, that is low speed. And second membership function, so this is rated speed. Let us take it as when voltage is 100, no change in speed, or when speed is 100, so speed is 500, no change in voltage, that is 100 only. So here 200. And third membership function is increase. That increase is more than 100, right? So here 100, 200, again 200. Now we have given the membership functions for the input output, that is speed and voltage. I'll frame the rules. So if speed is low, what we need to get? We need to increase it. Then voltage is increase. That means if speed is low, voltage is increased. Add this rule. First rule is added. If speed is low, then voltage is increased. Second rule, if speed is no change. In the speed, if there is no change, then the voltage also no change. Add this rule as a second rule. If speed is high, then voltage need to decrease. So this rule also I have added. Then close. Now we have given the membership functions for speed. For voltage also we have given membership functions, and rules also we have framed. Now you need to save this file. If you close this file, it will ask you to save the file. Otherwise, simply you can go to the file, export to file, and here already I have taken that location. Earlier I have saved. So now I have with the same name. For the motor speed control, extension is .fis. It will take as dot extension as .fis. Save. I'm replacing the same file. Now this is your fuzzy. So already I have saved. Save it. Yes. So now what you need to do? Now you have framed the fuzzy logic controller with membership functions and rules. Now you need to read that FIS file. First you store that into some variable. So read FIS of the same name what you have given file name. That file name, this location also you need to set. Here that path, I have created the same path, and here I am copying the same name. Dot FIS. So here you need to close with colon, then enter. Now we have read, and the values are stored into the test file. Now you need to go for eval FIS, that is evaluation of FIS file. So here for 500 rpm or for 1000 rpm or for 200 rpm, what is the corresponding values that it will give? For example, if I am giving, so here what I mean to say is, so to evaluate that FIS file, we need to enter eval FIS in bracket. You need to enter the corresponding speeds. Let it be 500 test. 500 is a rated speed, and test. So if you enter, you get the corresponding rated speed. So the corresponding rated speed has been shown here as eval FIS 500 test means 100 volts. You got it, rated voltage. So if you reduce the voltage speed, let it be 400 or 200. Corresponding to that, your voltage need to be increased as per your given rules. Voltage has been increased or voltage is more than that 100. Now if your speed is increased beyond rated, that is let it be 900 rpm. So your voltage should be less than the rated, that is less than 100, it is 64. So in this way your rules are working properly and this voltage can be given to the motor. So to see that surf view of test, then you'll get the surface view between the voltage and speed. Voltage is on y-axis, speed on the x-axis. For the rated speed at 500 here, the corresponding voltage is 100 volts. If it is below the rated speed, your voltage is increasing. Above the rated speed means your voltage is decreasing. That's what you can observe here, right? In this way we are given the rules. So here directly you can go view and you can see the rules also. So at 500 the corresponding voltage is 100. For less than 500 rpm, see here, for less than 500 rpm the membership function 1, that is low speed membership function, is intersecting with this red color vertical line. The corresponding high voltage or increased voltage membership function is intersecting. So the below that intersecting point, this one, so corresponding to this it will intersect at here. So the below one is hatched portion are blue color, corresponding to this again here. So this third membership function, it is not intersecting with the given speed, so there is no voltage intersection also. Overall you are getting the 121 volts. Even to see that rule view, here you can enter the command also, rule view of test, the same thing, surf view, rule view, even membership function editor, mf edit of test. Look at this. Here you can change the membership function values also, ranges also. So in this way we can implement the fuzzy logic controller in MATLAB. The same fuzzy logic controller what you have given as a rules, the same name, there is nothing but fuzzy motor speed controller, can be called in Simulink block, fuzzy controller block. So the same fuzzy controller block is available in the MATLAB Simulink. So in the Simulink, if you open, it will ask the file name, that FIS file name. This same file name we can provide over there, so that the same rules will be applicable over there also. Because like PA controller, you have fuzzy controller also, fuzzy controller in the Simulink. So for fuzzy controller also single input, that is input, output. You have input, if you provide as a speed, output you will get it as a voltage. That voltage will be connected to the motor. So here in the closed loop you can get the speed from the motor, and that speed will be connected to the fuzzy controller, and fuzzy controller output will be connected to the again motor. So here in the closed loop we will see that fuzzy controller implementation in MATLAB Simulink also in the next sessions. Thank you.